Hey guys, Dr. Brown here with some Algebra 2 fractions and inequalities. Whoa, so let's get after it. All right, we have an equation here. 2 minus 3 over a is greater than 5 over a. Whoa, what to do? Well, we've been studying about getting rid of fractions, so let's just multiply a over 1 times every item. Now we could put a parentheses around and say I'm multiplying by a and then distribute it to each item, but let's just do that anyway. Alright, so 2 times a over 1, if I had a parentheses, minus 3 over a times a over 1, and in theory that's greater than 5 over a times a over 1. So I've multiplied every term by a over 1. So 2 times a over 1 is 2a minus, these a's cancel, minus 3. And that's greater than, these a's cancel, that's 5a. Excuse me, the a's canceled, times 5. Okay, so 2a minus 3 is greater than 5. The fraction has been greatly simplified. Now let's, for the moment, imagine this is equal. Knowing that we get a solution for a, that it can't actually be that number, it can approach that number but not equal it. But for now, let's say it's equal. So 2a minus 3 plus 3 equals 5 plus 3. We've just simply added 3 to both sides. Those 3's cancel. So I end up with 2a equals 8. Divide both sides by 2. 2 divided by 2 is 1. 1 times a is a. 8 divided by 2 is 4. So a equals 4. Well, it doesn't equal it, so I'm just going to put an open circle there. Let's go back to the original equation. You'll notice if a equals 0, this thing is undefined. So it can't have that either. So I'm going to put an open circle at 0. Looks a lot like a 0. Okay. All right. What this means is I have numbers that could be less than 0. It could be in between 0 and 4, or almost at 4. So I've got that zone. But it also could be greater than 0. So I have 3 different zones there that I need to evaluate. So let me take negative 1. I'll let x or a equal negative 1. And then I'll let a equal 1. That'll put me in this zone. And then I'll let a equal 5. We'll evaluate each one of those to see if in fact this side of the equation is greater than the other side. So let's try that. All right, let's try 1 first. Let's just get in here. So we have 2 minus 3 over 1. And that's supposed to be greater than 5 over 1. So 2 minus 3 is a negative 1. Well, that's not greater than 5. Okay, so this zone is false. It's bad. It's no good. This side is not greater than that side. Okay, now let's try the negative 1. So let me just put the negative 1 here. So I have now 2 minus a negative 3. Is that greater than a negative 5? Minus a negative plus a positive 5 is in fact greater than negative 5. So this side is true. It is greater than. All right, what about with a equals 5? Let's go back to this and we're going to put in 5 and a 5 here for a. Well, all right, let's get a common denominator of 5 here. So I need to multiply this by 5 over 5. So 5 times 2 is 10. 10 over 5 is 2, what I had originally, minus 3 over 5. Is that greater than 5 over 5? So that's 7 over 5 is in fact greater than 5 over 5. Okay, so on this side, the right side of greater than 4 would also be true. So on the right side of 4, is that a math term? All right, so we have two zones. What does all that mean? Well, A to be true would be less than 0, or A could be greater than 4. Greater than 4 is true, less than 0 is true. So that would be solutions for that inequality. And then you can see how we went through and got rid of the fraction, which helped it look a little bit better for us. All right. And the process of doing this is the same in every one of them. Some fractions obviously a little bit more complicated to get rid of than others. Some you may have to use least common multiple, prime factorization methodologies to try to get the answer to what the least common multiple might be. So there's a variety of tools that are out there. All right, let's take 2 over x plus 3 over x less than 10. I'm going to multiply through by x over 1 times 2 over x plus x over 1 times 3 over x is less than x over 1 times 10. Well, these cancel, that's 2, plus these cancel, that's 3, less than 10x. Well, I have 5 is less than 10x. Divide both sides by 10. So x, and I should have set that equal, by the way. We're trying to solve it if it's equal. So x equals 1/2. Now obviously it can't equal 1/2, so here's 1/2. We're going to put a circle there. So that's 1/2. So now, oh, and x can't equal 0. We have that same scenario here. So we have this real skinny zone right here between 0 and 1/2. We can be less than 0. We can be greater than 1/2, or in between. So let's say, let's let x equal 1/4. And x equal -1, and x equal 1. So let's try that. All right, let's try 1 first. 2 over 1 plus 3 over 1, is that less than 10? So 2 plus 3 is 5. 5 is in fact less than 10. So it's true out here. What about -1? -1, -1. What do we have? We have a -2 minus 3. Is that less than 10? Minus a positive is plus a negative, so -5 is in fact less than 10. So out here at x equals -1 or less than 0, that's true also. This is going to be very similar to the last one, isn't it? All right, so in between we were going to let x equal 1/4. So we're going to put x equals 1/4 here. Well, I have to invert and multiply. 4 times 2 is 8, plus 4 times 3 is 12. Is that less than 10? No, it is not. 20 is not less than 10. So it's false in here. So in this case, x can be less than 0, or x can be greater than 1/2. Those would be solutions for that inequality. Okay? Again, like I said, the process is pretty much the same on every one of them. Just sometimes the fractions are, oops, I erased my number line, didn't I? But that's okay, I don't need it for this one. All right, y minus 3 over 5 is less than y plus 2 over 10. What do you think we should multiply by? How about 10 over 1? Okay, now let's see, 10 over 1, I'll put it down here, times y minus 3 over 5 less than, let's go ahead and set it equal before I forget it, y plus 2 over 10 times 10 over 1, okay? Now then, 10 divided by 5 is 2. We have 2 times y minus 3 equals, these 10's cancel, so I end up with y plus 2. So 2y minus 6, all I've done is distribute into the parentheses, 2y minus 6 equals y plus 2. Well, let me subtract a y from both sides. Y minus y cancel, 2y minus y is y. Y minus 6 equals 2. Let me add 6 to both sides. Y, those 6's cancel, y equals 8. Alright, so here we are, we have a number line. Now it can't equal 8 because it's an inequality. So here we are at 8. Can't touch 8, but I can either be less than or greater than 8. So let's just say 7 and 9. Okay, so let's plug that in. We have 7 minus 3 over 5 should be hopefully less than, maybe not, 7 plus 2 over 10. So I need to change this to 10, so 2 over 2 multiplied by that would give me 2 times 5 is 10, and 7 minus 3 is 4, 2 times 4 is 8. 8, is it less than 9 over 10? Hey, well, it is 80% and 90%, so it is less than. So this is good. This is true. All right, what about 9? So now if we had y equal 9, 9 and 9, so we still have the same scenario. 9 minus 3 is 6. 6 times 2 is 12. 2 times 5 is 10. Less than 11 over 10. So 12 over 10 is not less than 11 over 10. So this is false over here. Alright, so what does that mean? Y has, for the solution here, y has to be less than 8. Alright, so we've used a few tools here to reduce the fraction, actually eliminate the fractions and get it into a non-fracture equation. And then just used set it equal, solve for the variable that was of concern. And then once we find out a solution that it's equal, start looking on each side of that. But also, if you know, the previous problems we had some issues where 0 could not be defined. The equation was undefined at those points, so we had to address that, and that created another region that we needed to look on each side of. So identify the regions, look on each side of the regions, and see if in fact it meets the inequality demand. And that's all there is to it. Hey, practice, guys. Practice, practice, practice. That's how we're going to get better and build a better tomorrow. And do that through math. We're going to practice, okay? All right, that's enough for now. Keep practicing, and we'll talk to you next time. Thanks.